Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Now, this second video lecture of week 12 is the continuation of my previous first video lecture of week 12. In the first video lecture, we have discussed techniques of integration in the integration by substitutions. So, in this video lecture, today we are going to learn about another techniques of integration, which is called integration by parts.
Integration of a function by using the by parts formula. So integration by parts rule, we learn some of the basic technique of integration to solve the problems like integration of x cube with respect to x and integration of sine x with respect to x. So these are very basics. So the integration of x cube with respect to x by using the definition of integration. So I have already told you that adding 1 with the power and adding 1 with the power in the denominator, we can obtain the integration of this function will be equal to x power 4 divided by 4 plus c, where c is the constant of integration. And the integration of sine x is equal to minus cos x, because the derivative of cos with respect to x is equal to minus sine x. So the integration of sine x is equal to minus cos x. Now, dear students, I have already told you that derivative integration are anti-process for each other. These are anti-operators. Now, but how do we evaluate an integral whose integrand is the product of two functions such as integration of x multiplied log x with respect to x, or sometime integration of x multiplied e power x with respect to x, or integration of x multiplied sine x with respect to x. So in these integrals, you see over here two functions are in the multiplied form. In the previous video lecture, I have already told you that when two functions are in multiplied form or two functions are in divide form, we can use the substitution method. And two other rules. One rule is for the quotient. If suppose integration of 1 over x with respect to x, the integration of 1 over x is with respect to x is equal to log x. Why? Because the derivative of the, if we take the derivative of the denominator, we obtain the result of the numerator. So in this case, we take the natural log of the denominator for the integration. And sometime when two functions are in multiplied form, we check the derivative of the first function. If after taking the derivative of the first function without its power, we obtain the result as like the second function, then we add 1 with the power of the first function, and adding 1 with the power of the first function in the denominator, we will obtain the integration. But after using these two rules, if we do not use these two rules, and we cannot evaluate the integration by using these rules, so sometimes we use the substitution method in the form of product and quotient. So when two functions are multiplied and two functions are in divide form, we can use the integration by substitutions. But sometimes we use integration by parts when two functions are in multiplied form, like you see over here in these examples. Here polynomial and logarithm function are in multiplied, polynomial and exponential function are in multiplied, polynomial and trigonometric function are in multiplied form. So to solve the integral of these type, you see over here, we have technique called integration by parts. For this techniques, so recognition of integration by parts formula. For this technique, recall the differentiation of the product of two functions, which I have already told you in the technique of differentiations, that when two functions like f function, g function are in multiplied form, and the independent variable of these two functions is x. So the derivative in the form of product of these two functions, you see here, write first function as it is and take the derivative of the second function with its independent variable plus second function into derivative of the first function with respect to its independent variable. So this is actually called the product rule of differentiation. Now we obtain derivative of the product of two functions f and g is equal to f function into g prime. G prime mean derivative of the g function, and g function actually here consider as a second function, plus g function into prime of x. Prime of x mean derivative of the first function f. Now we can write f into g prime is equal to derivative of the product of f into g minus g into f prime. So taking integration on both sides, we obtain integration of f into g prime of x with respect to x is equal to integration of derivative of the f dot g minus integration of g dot f prime with respect to x. Now, since derivative and integration are reciprocal are inverse operator, so in this term we obtain f into g function minus integration of g function into f prime of x with respect to x. So the equation that can be transformed into more convenient form by substituting u is equal to f of x and v is equal to g of x and du is equal to f prime of function f with respect to x and du is equal to g prime of the function x of the function g with respect to x. So we can write integration of u into du. In place of f we put u, in place of g prime we put du. So integration of u into du is equal to u into v minus integration of u into du. So dear students, this is the formula by parts. In this formula you see over here, this is actually the first function. Write the first function as it is and take the integration of the second function minus, actually u is the first function, u is the first function and v is the second function. So you see over here f into g of x and du represent derivative of the g function and du represent derivative of the first function. So in this formula you see over here this v represent the g function and u represent the derivative of the first function, and this u represent the f function and v represent the g function, and this is the integration of the u is the first function and du is the derivative of the second function. So we call this formula as first function as it is, integration of second function minus whole integration derivative of the first function and integration of the second function. So this is the standard form of the integration by parts formula. I would like to tell you again, integration by parts when two functions are in the multiplied form. So write first function as it is and take the integration of the second function minus whole integration, take the derivative of the first function and take the integration of the second function. So this is the integration by parts formula. For example, you see over here in this example, one function is a polynomial and other function is a trigonometric. So in this case these two functions are in multiplied form, but the main problem for the student is that which function should be considered as a first function and which function should be considered as a second function. So dear students, in case of polynomial and trigonometry, when polynomial and trigonometry are in multiplied form, then consider this polynomial as a first function because the derivative of this x is equal to 1. In the integration by parts formula, actually when we call the integration by parts formula, first function as it is, integration of second function minus whole integration like you see over here, minus whole integration derivative of the first function into integration of the second function. So derivative of the first function, if we consider x as a first function, then the derivative operator will be applied on this function. Actually in the integration by parts formula we apply two operator. One operator is the derivative operator and other operator is the integration operator. So in case of polynomial and trigonometry, consider the polynomial as a first function, then we apply the derivative on the polynomial, and when we apply derivative on the polynomial, the power of the polynomial will be decreases, and when the power of the polynomial will be decreases, then the product will not present after applying the integration by parts formula. Actually, the main problem, the main issue is the product of these two functions. That's why we use the integration by parts formula. So in the by parts formula, if we consider polynomial as a first function, then since we applied the derivative in the formula on the first function, and by applying the derivative on the polynomial, the power of the polynomial will be decreased, and then the product of two functions will not present after applying the formula. So for this purpose, when polynomial and integramentary are in multiplied form, then consider the polynomial as a first function. Like you see over here, suppose in this formula, first function is it is using the formula integration u into du is equal to u into v minus integration v into du. So u is equal to x, and d minus 2 into dv is equal to sine x by 2 into dx. So dx is equal to du and v is equal to cos x by 2. In simple wording, dear students, note that this is very easy for you. So write the first function as it is and take the integration of the second function. So in this problem, x is the first function. So the integration of the second function is sine x by 2, and using this formula, integration of sine kx with respect to x is equal to minus cos x kx divided by k. So the integration of the second function minus cos x by 2 divided by 1 over 2 minus whole integration derivative of the first function. So the derivative of the first function and integration of the second function. This is the derivative of the first function is 1, x derivative is 1, and the integration of this function, like you see over here, minus cos x, this is actually the second function. I would like to highlight this. This is actually the second function, and the integration of second function is minus cos x by 2 divided by 1 over 2. Now we can write minus 2 into x cos x by 2 minus minus plus integration 2.1 into cos x by 2. Now after simplifications, we obtain minus 2x cos x by 2 plus 2 into integration of cos x by 2 into dx. Now here in this part, you see over here, product is disappear. There is no product of two functions, only just only one terms, which is cos x by 2. So the integration of cos theta is equal to sine theta. So cos x by 2 integration is equal to sine x by 2 divided by 1 over 2. Now we obtain minus 2x cos x by 2 plus 2 into sine x by 2 divided by 1 over 2 plus c. So after simplifications, we obtain minus 2x cos x by 2, 2 to the 4 into sine x by 2 plus c. Now again, by using the integration by parts rule to evaluate the integral x square into cos x with respect to x. So dear student, in this part, in this problem, you see over here again, one is the polynomial term and other is the trigonometric function. So remember this point is very very important when polynomial and trigonometry are in multiplied form. So in the by parts formula, consider polynomial as a first function. Why we consider the polynomial as a first function? Because in the formula, in the by parts formula, we use two operators, a derivative and integration. So derivative apply on the first function. So when derivative on the first function, and the first function is polynomial, then after applying the derivative, the power of the polynomial will be decreases, and after decreases the polynomial, the power of the polynomial, the product will be disappear from the problem. So that's why we consider polynomial as a first function in the formula integration by parts. So now dear student, note that write the first function as it is, write the first function as it is, and take the integration of the second function. Integration of cos is sine x. Now minus whole integration derivative of the first function, you see over here, and integration of the second function. The integration of the second function is sine x with respect to x. So the integration of cos with respect to x is sine x. Now the derivative of this x square is equal to 2x, and sine x is it is. So After applying the integration by parts formula, now the product of the polynomial is decreases. Now we obtain x multiplied sin x. Now here two functions again are in the product form, the product of the polynomial and trigonometry. Now in this case again we use integration by parts formula, so x will be the first function and sine will be the second function. So again by using the integration by parts formula, so x square into sine x minus 2 into first function is it is an integration of the second function, which is minus cos x minus whole integration derivative of the first function, you see over here, derivative of the first function, and integration of sine, integration of second function is minus cos x. And this dx operator used for this integral symbol, because in this formula we call first function is it is integration of second function minus whole integration derivative of first function integration of second function. So in this part, in this segment, you see over here, taking the derivative of the first function and taking the integration of the second function. After taking derivative of the first and integration of the second, we again integrate the obtained result. So the derivative of this function is 1 and the integration of sine is minus cos. So after simplification we obtain x square sine x minus 2x cos x minus 2 into integration of 1 dot cos. So 1 dot cos means again cos, and the integration of cos, you see where integration of cos is sine x. Now the product is disappear because we consider polynomial as a first function. So when we consider the polynomial as a first function, in case of when polynomial and trigonometry are in multiplied form. Dear students, why we not consider trigonometric as a first function? If we consider trigonometric as a first function, we apply the derivative, and after derivative, the derivative of sine will be cos, and the derivative of cos will be minus sine. The term will not be disappear. And if we consider the trigonometric function as a second function, then again sine become cos, and cos converted to sine by applying the derivative in any integration. So the main point is the polynomial term. So if we consider the polynomial as a first function, we apply the derivative operator on the polynomial in the integration by parts formula, and after applying the derivative on the first function, which is polynomial, the power of the polynomial will be decreases, and due to decreases of the power of polynomial, the product of two functions will be disappear. Now again another problem, using the integration by parts rule to evaluate the integral x cube into log of x with respect to x. Now this is another case number 2. So dear students, note that now when polynomial and log functions are in multiplied form, polynomial and logarithm are in multiplied form, in this case we will consider log as a first function. So this will be the first function and this will be now the second function. Consider log as a first function. Why? Because the integration of a logarithm function is impossible. So for that purpose, for that integration, the integration of log x with respect to x, we put 1, and 1 dot log x will be the product of two functions. So we consider log x as a first function when 1 is a second function, because the integration of 1 with respect to x will be x, and the derivative of log x with respect to x will be equal to 1 over x. That's why in the product of polynomial and logarithm, we consider logarithm as a first function, because if we consider log function as a first function, then we apply derivative on the log function, and we apply the integration on the trigonometric function, on the polynomial function, sorry. So in the product of polynomial and logarithm, we consider logarithm as a first function, and by considering log function as a first function, we apply the derivative on the logarithm and we apply integration on the polynomial. So now you see over here, first function, right? First function is it is in this formula. You see over here, log is a first function and x cube is a second function. So write the first function is it is, and integration of the second function, x cube plus 1 divided by q plus 1 minus whole integration derivative of the first function, you see over here, and integration of the x cube with respect to x cube 3 x power 3 plus 1 divided by 3 plus 1, and this dx operator is now represent operator for the this integration symbol. Now after simplification we obtain x power 4 divided by 4 log x minus derivative of log x with respect to x of 1 over x and x power 4 divided by 4 as it is. Now after simplifications we obtain x power 4 into log x minus 1 over 4 integration of x cube with respect to x. Now the product is disappear, and the main advantages is considering the logarithm function is a first function and the polynomial function is a second function. So the problem is evaluated very easy. So dear student, note that in the product of polynomial and trigonometry, consider polynomial as a first function, and in the product of polynomial and logarithmic function, consider polynomial as a second function and logarithm as a first function for the integration by parts formula. Then we can evaluate the integral of the product of polynomial and logarithm very easy. Now you see over here the obtained result x power 4 divided by 4 natural log of x minus x power 4 divided by 16 plus c. Now another problem you see over here to evaluate the integral by the integration of 4x into secant square 2x with respect to x. So in this problem 4x is the polynomial and x square is the trigonometric function. So we obtained the polynomial as a first function, and this integral like you see over here, write the first function 4x as it is, and the integration of secant 2x is equal to you see the integration of the derivative, actually the integration of secant square kx is equal to tangent kx divided by k, because the derivative of tangent kx is equal to k into secant square kx. So the integration of secant square kx is equal to tangent kx divided by k. Now 4x is a first function. Write the first function as it is, in the integration of secant square 2x is equal to tangent 2x divided by 2 minus whole integration derivative of 4x and integration of the second function, which is tangent 2x divided by 2. Now the derivative of 4x is equal to 4 and tangent 2x divided by 2 as it is. Now again the integration of tangent 2x with respect to x. So 2 to the 4 we obtain 2x minus tangent 2x minus 2 into integration of tangent 2x with respect to x, and this implies that 2x tangent 2x minus 2 into sin tangent 2x can be written as sin 2x divided by cos 2x. This is the rule which I have already told you in the previous video lecture, that when two functions are in divide form, in this case we have two options. We can use the integration by substitutions, and we can use this rule. This rule stated that if the derivative of the denominator is appear in the numerator, like you see over here, the derivative of cos 2x is equal to minus 2 sin 2x. So in the denominator we have already obtained minus 2 into sin 2x. So from the derivative of cos 2x, from the derivative of the denominator we obtain the result of the numerator. So in this case we can take natural log of the denominator for the integration, because we have a simple example, the derivative of log x is equal to 1 over x and the integration of 1 over x with respect to x is equal to log x. So that's why now integration of minus 2 sin 2x divided by cos 2x is equal to natural log of cos 2x. In this case you see over here the denominator function is equal to cos 2x and the derivative of this cos 2 is equal to minus 2 sin 2x, and we have already obtained this result in the numerator. So we obtain the integration of this term is equal to natural log of cos 2x. Now the result of the given problem is 2x into tangent 2x plus natural log of cos 2x plus c. Now another problem, using the integration by parts rule to evaluate this integral p power 4 into e power minus p with respect to p. So this is the third case when polynomial and exponential function are in multiplied form. Dear students, I have already told you that the integration of the exponential function is as it is, and similarly the integration of the exponential functions also as it is, and we can take the further derivative of the argument of the argument in the derivative. So the result obtained from the further derivative of the argument will be written in the product form and will be written in the quotient in the divide form in case of integration. Now this is the new case number 3 for the integration by parts when polynomial and exponential function are multiplied. So the integration of exponential function will be as it is, and the derivative of the exponential function also will be as it is. So that's why we consider polynomial as a first function to reduce the power of the polynomial. By reducing, due to reducing of the power of polynomial, the product of these two functions will be disappear after applying the integration by parts formula. So in this case, we also consider polynomial as a first function. So consider polynomial as a first function. So you see over here, first function is it is, like in this formula, p power 4 is it is, and in the integration of the second function, and I have already told you in this references that the integration of e power x with respect to x is equal to write the exponential function as it is and divide by the result obtained from the further derivative of the argument. Derivative of the argument ax with respect to x is equal to a, so divide by a. Now first function is it is, and integration of e power minus p is equal to e power minus p divided by minus 1 minus whole integration derivative of first function integration of the second function. And now this dp is operator for this integration. Now the derivative of p power 4 is equal to p power 4 into p power 3 by using the power rule, and e power minus p is it is, and minus minus plus. Now you see over here, when we p power 4 consider as a first function, the power of p power 4 reduced to p power 3. Now again, power product of p power 3 and e power p minus p is a pair. So for due to this product, now we again using by parts formula. So this in this result again we consider p power 3 as a first function. So minus p power 4 into e power minus p plus 4 into, now we start again by parts formula, p power cube as it is, and the integration of the second function e power minus p divided by minus 1 minus whole integration derivative of the first function and integration of the second function. The integration of this second function you see over here, e power minus p divided by minus 1, and this dp represent the operator integration for this operator, the integration with respect to dp from of the obtained result. So the derivative of p cube is equal to 3p square by using the power rule. You multiply the power with the coefficient and subtract 1 from the power. So now we again in this case the product rule. So 30-15 मिनट पाती थी और 10 स्लाइड ना पाती थी. نو ته پته چې سټوډیو کې ټول آنلاین روان دي. په کار 4 بجې نه پس دي دا کار کوي یا سهار لږ مخکې کوي. دا خو ډېر سنسیټیو څیزونه دي. معمولي تار هم خوځي راخوځي اواز خوځي بس مسله جوړوي. نه کله کله دیوال خوځېدو سره هم تارونه مارونه ګډوډ شي. ټول هارډ بورډ دي خښته خو نه ده. Now again in this step you see over here we obtained the product of p square in e power p. So again for the integration we use integration by parts formula. So p square is a first function like you see over here, minus p power 4 e power minus 4 minus 4 p power cube e power minus p plus 12 n2. Now p square is a first function in the integration of the second function minus whole integration derivative of the first function integration of the second function. So this is the integration of the second function, and derivative of the first function p square is equal to 2p. and e power minus p is it is, and this minus minus plus. Dite break por esa baroka. Yeah.
सर यो 5 मिनट ब्रेक वर्को सर
हाँ
अभी जगह विच दे दे कंप्लीट की बस
हजुर ما سره 10 نمبر سلاید روان دی کنه او په 13 نمبر سلاید باندې یو ټاپک ختميږي او په 14 نمبر باندې بل ټاپک شروع کیږي نو موږ سره باقي څونه منټ پاتې دي
15
نو ستا مشوره څه وي چې دا باقي چې کوم څو سلایډه پاتې دي باقي 3 سلایډه پاتې دي دا باقي 15 منټ په 3 سلایډو واړو که ټاپک ته وړو
ټاپک په څونه ټایم خپل دی پلان
یا دا 3 سلایډه خو دیوالي یو منټ دیوالي نو دغه ټاپک چې دا پاتې شو بیا 2 سلایډه نور پاتې کیږي نو کم از کم 15 منټ خو هغه اخلي 15 اور مطلب چې ماته یو 20 منټ یا 22 منټ ملو شي دا ټاپک په دا لیکچر په ټول راغون شي څونه ټایم شوی دی
30 minutes
30 بس ماته 20 منټ نور پکار دي نو 30 او 20 50 شي بس خیر دی دا لیکچر په ختم اچھا چې موږ چې کله بیا بل ټاپک ریکارډینګ سٹاپ دی روان دی سٹاپ دی کنه نو موږ چې بل ریکارډینګ بیا شروع کوو کنه بل لیکچر هغه د ټایټل غونډه سمې د پاره مې ویل چې هغه سره مې په سٹارټ کی کنه خو
خراب شي
نو مې سره بس خیر کولو دی دا نو خیال سړی ختم کړی
10 منٹ کار نه
دې په نو چې ریکارډینګ شو دی
هم ورته نه وکړو او په ډیل کړه دا په کوم نو ټیم کار کوي نو بیا هم ته نه وکړو
بالکل څه جوړی کسه کوي
کنیکشن ورکړي
چې سړی خاموش شو ها دلته په هغه مېړه یو مډم لګی دی هم خاموشه ده
ټول
اوکه خر بچیه څه کوي أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الله لا إله إلا هو الحي القيوم لا تأخذه سنة ولا نوم له ما في السماوات وما في الأرض من ذا الذي يشفع عنده إلا بإذنه يهديه وما خلفه لا يحيطون بشيء من علمه إلا ما شاء وسع كرسيه السماوات والأرض ولا يؤوده حفظهما وهو العلي العظيم لا إكراه في الدين المجتمع الغية ومن يكفر بالطاغوت فقد استمسك بالعروة الوثقى لا انقسام لها والله سميع عليم.
Ready, sir?
Yes, sir.
Sure.
Now, in this step, you see over here the derivative of p square with respect to p by using the power rule is 2p. Now, we obtained again the product of p and e power minus p. So again, integration by parts formula. All these steps, all these term will be as it is. And for the integration by parts formula, we obtain now p will be considered as a first function, and integration of e power minus p is equal to e power minus p divided by minus 1 minus whole integration derivative of first function and integration of second function you see over here, and this dp operator for the this integration. Now we obtained all these strips can be written as it is plus 24 you see over here integration of derivative of p with respect to p is 1 and integration of this e power minus p. Now integration of e power minus p is equal to e power minus p divided by minus 1. So plus c is the constant of integration. Now the overall result of the given problem is equal to minus p power 4 e power minus p minus 4p cube minus e power p minus 12p square e power minus p minus 24p into e power minus p minus 24 e power minus p plus c. Now another problem, the integration of t square into e power minus 4 e power 4t with respect to t. So in this problem you see over here t square is the polynomial and e power 4t is the exponential function. So again t square consider as a first function, so first function is it is, and the integration of e power 4t is equal to e power 4t divided by 4 minus whole integration derivative of t square is equal to 2t, and the integration of e power 4t is equal to e power 4t divided by 4. Now the t square power is reduced to t power 1. Now again we obtain the integration of t e power 4t which is in the product form. So again t consider as a first function, so you see over here t square e power 4t divided by 4 minus 2 into t consider as a first function as it is, and in the integration of second function e power 4t divided by 4 minus whole integration derivative of t is 1 and integration of e power 4t is equal to e power 4t divided by 4. Now the derivative of t with respect to t is 1, so in this term now the product of two function is disappear and we have only the one term integration of e power 4t with respect to t which is equal to e power 4t divided by 4. So the obtained result of the given problem is t square into e power 4t divided by 4 minus 1 over 2 into t e power 4t minus e power 4t divided by 8 plus c. Now another problem to evaluate the integral by parts, x square minus 5x into e power x with respect to x. So in this problem x square minus 5x is the polynomial, so this polynomial will consider as a first function. So for write the first function as it is, and the integration of e power x is it is, minus whole integration derivative of x square minus 5x with respect to x is equal to 2x minus 5, and in the integration of e power x is equal to e power x divided by a. So by using this formula we obtain the integration of e power x is equal to e power x divided by 1. Now 2x minus 5 and e power x again in the product form. So again applying the integration by parts rule, for 2x minus 5 consider as a first function. So first function and integration of second function minus, like you see over here, x square minus 5x e power x as it is, minus first function integration of second function minus whole integration, but minus minus plus whole integration derivative of the first function which is equal to 2, and integration of the second function e power x. Now using integration by parts formula, now we obtain e power x, only the one term, integration of e power x is equal to e power x. So the obtained result is equal to x square minus 5x into e power x minus 2x minus 5 into e power x plus 2 e power x 2 into e power x plus constant of integration. So this is the procedure for the integration by parts formula. So in case of integration by parts formula, we have two functions are in the product form. So when polynomial and trigonometry are in multiplied, consider polynomial as a first function and trigonometric function consider as a second function. Similarly, in the product of polynomial and logarithmic function, consider logarithmic as a first function and polynomial as a second function. And in the product of polynomial and exponential function, consider polynomial as a first function and exponential as a second function. And in case of product of exponential and trigonometric function, we either consider exponential function as a first function or either consider trigonometric function as a first function. And after applying in trigonometric by parts formula, at some stage the question will be repeated. So at the start consider the question is equal to I, then in the obtained result when the question repeated, then for that term put I and shift I from the left hand side to the right hand side, we obtained I plus I which is equal to 2I, and then dividing both sides by 2 you will obtain the result of the given